All right, here we're getting to function operations. So we're doing -2 times g of x plus f of x. So we need to take the g of x and double it. So I'm going to do that first. Basically, you're just distributing a -2 to this thing. So you're doing -2 times, and I'm going to write the g of x here, x squared minus 3x plus 2. And you can do this mentally pretty well. Like there's really not a need to write it out. I'm just showing you what I'm doing. That's -2x squared. That'll be a plus 6x because you're multiplying two negatives, and then minus 4. And I'm going to take that and I'm going to add to that x minus 2. So just to be clear, this is coming because that's what g of x is. And this yellow thing right here is coming from the f rule right here. Now, if I was subtracting, I would want to put parentheses here because you'd have to distribute the negative. Since I'm adding, there's not really a need to put the parentheses. I mean, you could put them, but now all I'm going to do is just combine like terms. Combine this x term, 6x, with this 1x, and combine this -2 with this 4, and you write. So you get -2x squared plus 7x minus 6 when you combine the like terms there. All right, that's the answer for number 18. But then they asked to find the domain and range. Now, because this is a polynomial, when you're checking for domain specifically, okay, look for the domain. Remember, those are the x values that you're allowed to put in. And when it's a linear function, which is a subset of polynomials, or just in general a polynomial function, your domain is all real numbers. So for my domain, it's every number from -infinity to infinity. Now, my range is a lot harder to tell just by looking at it, but what I advise for you to do, and if you're trying to determine the range, I advise take a look at the graph because that's graphically, domain and range don't have a lot of meaning unless you're looking at the graph for them. So go ahead and put this function into your calculator and then just graph it, and hopefully the standard window will work well for us. So if you do zoom 6, it would be nice if we can see that. Oh, that's the range is the y values that it hits. Now, um, I'm going to try to defend my answer that the domain is all real numbers. I know you might be thinking, oh, it only goes so far left and so far right. But if you zoomed out on this function, I promise it would keep going. It would just keep going off to the left here, off to the right here. So you can see that trend. But it's pretty obvious that this function isn't going above whatever the maximum value is. So because this is an upside down parabola, it's going to have a max. So using second calc max, and I'm going to left bound and then right bound that value. And so you get a maximum value, it seems to be at 0.125. That's the highest y value we seem to. So your range is from -infinity to 1.25, or you could say it this way. If you want to say your domain and range a different way, you could say your domain is all reals. And then for here, you could say the range is all the y values less than or equal to 0.125. If you want to avoid using a calculator, because we have a quadratic equation, remember you could use -b over 2a. You can use that to figure out where your vertex is of your parabola. And if we do that, we get -7 over 2 times -2, which gives you -7 over 4. And that only gives you the x value. You then have to go and take that and plug it in to get your vertex, which is either your min or your max. So you could go to second, your value. If I plug in -7 over 4 into my, oops, actually it should be +7 over 4 because it's negative b over 2a. These, I forgot to cancel out these two negatives here. So it's +7 over 4. So notice how you get the same answer there. But I advise just looking at the graph of the calculator. That helps do it as well. But if you want to do it without a calculator and plug this value in, you can do it that way too. So just remember we're just simplifying these functions, and domain, x values, range is your y value. The range is something, since it's so time consuming, notice how the question only asks for a domain. Range is something I would maybe ask you for a bonus. So if that's too time consuming for you, I'm not going to ask it, just like the study guide doesn't ask for it. I'm not going to require that. It's just something that I want you to get used to being familiar with soon. For 19, instead of adding the functions, now we're multiplying. So we have negative f of x. Now here's the thing, there's a negative in front of the whole function. So again, you want to use parentheses most of the time, so this negative kind of distributes. It's going to be negative f of x multiplied by g of x. Now let me finish that and then write the parentheses. So what you're going to have to do is you're going to have to multiply, like you have to distribute. I don't want to say FOIL, because if you FOIL, you'll skip over this middle term here. You have to distribute these. And notice how I skipped over the negative? I'm going to do that part last. You can, a lot of people just prefer to do it this way, multiply these top terms, and you get x cubed minus 3x squared plus 2x. And because these are in descending order, if I do the little blue, you get negative 2x squared plus 6x minus 4. And if you write them, you could write them side by side and like circle the like terms, but if you organize it this way, it just makes it easier to see which like terms combine. And so we get x cubed minus 5x squared plus 8x minus 4. And that negative is still here, okay? So this negative, I'm going to introduce right here, and it negates that whole thing. So your final answer is negative x cubed minus 5x squared plus 8x minus 4. Again, because this is a polynomial, and I know it's a polynomial because all the powers are positive powers, or they're like here, this is technically 4x to the 0, so that's still, it's either positive powers of x or a constant. There's no x in the denominator, there's no square roots or anything, so the domain of polynomials is all real numbers. So for my domain, I put negative infinity to infinity or all rails. And be careful here, so I'm supposed to put that negative in front of everything, so that negative 5x squared, it's a positive right there. This is a negative 8x, and that's a plus 4. So, yeah, make sure you distribute your negative to everything. So don't forget to do that. For number 20, this will be the only case where you have to worry about this domain question. When we're adding, subtracting, multiplying polynomials, you'll always get another polynomial. But when you divide two polynomials, you're not always going to get another polynomial. So, and if you remember, we can't divide by 0, so when our denominator is 0, that's going to give us an issue. So let's just write this thing. So this is x squared minus 3x plus 2, and then that's your g of x, and we're going to divide by f of x, which is x minus 2. Well, that is just written out. That works out. But there is a possibility like that we could simplify this. Let's try factoring the numerator. Well, I know x and x gives me x squared. What's the only way to get 2? That's 2 times 1. And let's try, if we put two negatives, negative 2 times negative 1 would give you a positive 2. And that would work out for the minus 3. So in a way, this, this x minus 2 right here kind of cancels out, okay? But in the original function, you still can't put a 2 inside of x, because here's what would happen if you put a 2. 2 minus 2 is 0. You'd end up dividing by 0. So the simplified version of this is the function g of x over f of x is x minus 1. But you cannot have x be equal to 2. So your domain is, x is not equal to 2. Some people write the domain this way. Your domain is all real numbers with the condition that x is not equal to 2. Really, I want you to just write it like this, x is not equal to 2 like this, or write if you want to say all reals except for 2, you could say it that way too, but this is just a really concise way of saying it. Just note that in college, you might get some professors that really prefer you to say this because what would be wrong is if you said the domain was x equals 2, because that's the one thing it's not. But most people will like, understand what you mean when you say x not equal to 2. They assume you mean everything else but that. For number 21, we're going to run into an issue here. Now, you can run this in your calculator, but you'll get a decimal. We want to keep this in radical form. We want to keep this in exact form. If you do this in your calculator, it'll give you an approximation. Okay, so leaving this in radical form is just really difficult to compute. So let's try writing it in exponential form. Square root of 5 is 5 to the 1/2. Fourth root of 5 is 5 to the 1/4. So if we look at these two functions, 5 to the 1/2, 5 to the 1/4, well, we can apply this rule. When they have the same base, you can add the powers. 1/2 is the same as 2/4. So this is 5 to the 3/4 power. Now, because even though this is right, because they gave us it in radical form, and a good rule in life is leave things the way you found them. You found the problem in radical form, so leave it in radical form. So instead of writing 5 to the 3/4 power, it's preferable that you write this in radical form, which would be 5 to the 3rd power and then 4th rooted. You could also write it this way. 5 to the 3rd is 125. So you could write the 4th root of 125. I would personally accept either of these answers. Even though this is right, I'd really prefer that you leave it in radical form. But the most simplified answer would be this last one right here. For number 22, again, trying to simplify radicals that have different indexes seems like you're just not able to do anything. So we know that we can divide and multiply radicals when they're the same index. When they're not the same index, it can help a lot to write it in exponential form. And then it's a lot more obvious what our options are. Well, we remember that when you're dividing powers that have the same base, in this case x, that we can subtract the powers as a shortcut for when you're dividing. So I do x to the 3/2 minus 2/5. Now I can do this by hand, but I have a calculator. Why not use it? Let's do subtraction of fractions. 3/2 minus 2/5, which gives me a decimal, but I'd rather that in fraction form. Use math and enter. So that's 11/10. So this is x to the 11/10. Again, because it started off with a radical, they seem to prefer a radical answer. So even though this is right as an exponential form answer, I'm going to write x to the 11th inside of a 10th root. Now this is correct, but it could be simplified. If you take 11 and divide it by 10, you get 1 remainder 1. So there's an x on the outside, okay? And there's an x on the inside, 1 of each. And don't forget your index of 10. So your final simplified answer looks like so it's x times the 10th root of x. Next, we're going to practice composing functions with other functions. Remember, this symbol means g composed of x. So this right here is another way g of f of x. So you apply the f rule to the x, it spits out an output. Then you apply the g rule to that output of f of x. Same thing here if it's written the other way around. First, you apply the g rule to the x, then you apply the f rule to the output of g of x. So the order here is important. If we're going to do g composed of f of x, and I prefer to write it this way, g of f of x, we're going to first do f of x, then we're going to feed that into the g's argument here. G's argument is x, but we're going to feed the output of g's little input variable and then simplify that. So for that one, we get, you write the 4, and I'm going to use parentheses and put the x squared minus 2. I'm feeding that into this where this space for x is, and then I'm going to add 1. This is the correct answer. If it makes sense to simplify, it's a good idea. It's just nice to do that. So this becomes 4x squared minus 8 plus 1. And when you distribute, it actually gets easier and more easy to read. So 4x minus 7 once you simplify everything out. And let me swap these colors here just so that they're color-coded. So I'm going to do the f of g of x. I'm going to do that one in red. So for f of g of x, I'm going to take g and I'm going to put it into the x on the f. All right. So I'm going to take the 4x plus 1, the output of that result, and I'm going to feed it into something squared minus 2, where the something is the g. And so this is the answer for f composed of g of x. But since I have a constant here, I can go ahead and like FOIL this out. I can write this simpler if I want to. If you square this binomial, you get 16x squared. You get plus 4x plus another 4x. So you get plus 8x plus 1, and then subtract 2. And you can combine these like terms, which gives you a result of 16x squared plus 8x minus 1. So the order in which you compose them makes a difference. Unless they're inverse functions, the only time that composing two functions in different orders will give you the same result is if they're inverse functions, which these are obviously not. All right, so we're going to do more with composing. So for the first one, again, we're going to put the f inside the g. So we're going to take the output of f and put it inside the input variable for the g. So for g of f of x, or g composed of f of x, if you want to write it that way, we get -3. So in some ways, I like to start with the outside shell. -3 stuff minus 1. And inside of that, I'm going to put the f. So I'm going to put -3 of 2x squared plus x minus 7. And then don't forget the minus 1, which is part of the g right there. And we simplify if we can. So that comes out to -6x squared minus 3x plus 21 minus 7. And then you can combine like terms here. So you get -6x squared minus 3x plus 20. So your g of f of x, or writing it this way, g with the f of x inside of that, either way you write it, this is your expression. If we compose it the other way, where we take whatever g is, okay, and we put that inside of f, well, there's two places for an x for the f rule. So I'm going to write the frame first, and this time I'm going to color code. So this is the framework for f. Here's what f does. It takes stuff, it squares it, and then it multiplies it by 2. Then it adds that stuff again, then it subtracts 7. Well, that's what f does, but we're putting g inside of f. Okay, so we're putting the -3x minus 1 instead of putting x directly into it, we're putting how x is modified by g into that. So I'll put -3x minus 1, and then pretend like these are parentheses right here, and then -3x minus 1 in each instance that you see in x. So this comes to this expression right here. And we can combine like terms, but first I'm going to square this binomial. So first I'll square it, and then I'll multiply by 2, so that becomes like a 9x squared, because a -3x times a -3x. And then for the middle terms, you get a plus 6x. And then for the caboose term, you get a plus 1 there. And then you don't need the parentheses. Really, at this point, you don't need the parentheses for the second part. Minus 3x, minus 1, minus 7. The reason I kept these parentheses here is because now I got to distribute the 2. And you get 18x squared plus 12x plus 2 when you distribute that. And now we got to combine like terms. So there's only one x, 18x squared here. But the 12x and the minus 3x make a 9x. And 2 minus 1 is 1. So, and then positive 1, which I get from combining 2 with negative 1, minus a 7 is a negative 6. So this is your final answer, and this is the f of g of x. F composed with g of x. So the blue is g of f of x. The red is f of g of x. For the next section, we're finding inverse functions. So basically, I want to undo all this stuff. I want to find the inverse of x. So I like to replace this with a y. And it can be a little confusing to like swap the x with the y, but basically you're trying to like get x by itself. So instead of swapping first, I'm going to just leave it the x as an x. So I get y minus 1 is equal to x plus 3 squared. To undo a square, I'm going to square root it. Now this is technically a semi-illegal operation, just like squaring both sides of an equation. Square rooting, when you square root, you're supposed to do this like plus or minus thing. So we get plus or minus square root y minus 1 is equal to, now it's just x plus 3, and then we subtract 3 from both sides. So this is what your inverse function is. It's plus or minus whatever your variable that you feed it is, subtracted by 1, all inside of a square root, and then we subtract 3 from that altogether. But because you have, a top and a bottom side, like a plus or a minus, if you ask it one question, you're getting two answers. So the inverse function, I'm going to go ahead and change this y with an x, is plus or minus the square root of x minus 1, and then subtract 3 from that. Anytime in general you try to do an inverse function of something that has an x squared, it's not going to be a function. So this is not, the inverse is not itself a function. If you prefer, you could also write this as negative 3. You could write this as negative 3 plus or minus the square root of x minus 1 as well. You can write it that way. For number 26, one thing I noticed is that if we look at the domain and range of this function, you can't put just anything into x here. And also the range of this function is only numbers bigger than 0. So if you look at the domain of its inverse, we're only going to take a domain that is bigger than or equal to 0. So that'll be something I'll talk more about later. But let's just solve for the inverse. So we get y equals square root of 2x plus 1. If you want to do it the other way, if you want to swap the x and the y first, if that's your preference, I'll do it from the beginning, and then we solve for the new y. And the previous one, I swapped them at the end. So to undo all this, we got to square both sides. So we get x squared is equal to, just the little radicand drops out. And then subtract 1 on each side, so you get x squared equals 2y. X squared minus 1 is equal to 2y. And then divide by 2, so you end up getting x squared minus 1 over 2 is what your y is equal to. So that is your rule for your inverse function. So we get the inverse function is x squared minus 1 over 2. And since the range of this function is only positive, since this is principal square root, the domain of our inverse will be only positive. So we're only going to take numbers bigger than or equal to 0 for the inverse function. And yes, this is a function. For number 27, this will be a little bit easier to find the inverse of. So we got y equals 3x cubed minus 4. Again, you can, there's always some reservations about swapping the y with the x, because that can confuse what's really going on here when you start doing applications with these. But for now, it works as far as seeing like how to undo things. So we're just kind of using our inverse properties of algebra. You know, when you subtract, to undo it, you add. If you want to undo multiplication, you divide. And if you want to undo cubing, you cube rooting. So your final answer to get y by itself, you're going to have x plus 4 over 3. All of that inside a cube root is going to be equal to your y. And by y, we mean the inverse. So this is going to be the inverse of x right here. And since the domain and range of g is all real numbers either way, the domain and range of this is all real numbers. So there's no reason to look for any conditions on the domain. Yes, this one is also. All right, this is probably the easiest one. Y equals 1/4 times x. Another way to see this function is you take x, you divide it by 4. So if we have 1/4 x, if you want to swap the y and the x equals 1/4 y, and solve for the new y, you just multiply by 4 on each side. So 4x is going to give you the new y. So your inverse function is going to be 4 times x. Anytime you have a linear function, the inverse function is going to be another linear function. And this is a yes as far as the question, is this a function? And I'll end this video here, and we'll have one more much shorter third part.